Awesome. So we have our next speaker, Nico. Nico's up. He is going to give a talk. Basically, I need a C2 infrastructure immediately, as in yesterday, and I'll let you take it away and introduce your talk. Thank you.
Thank you. Thank you that you accepted me in this event. I'm glad to be here today. My name is Nikos Burdas, and for the next 45 minutes, we'll be together to present one of my latest research about C2 automation infrastructure. Um, First of all, I need to clarify something. That's the opinions and any view and opinions expressed in this presentation. They're my own and don't represent my current employer or any organization. Okay, who am I? As I said, my name is Nikos. My handle name is Nickwood or NCV. Um, I'm from Greece, but I live in the United States. I'm a senior offensive security consultant. I have experience in adversary simulation and expertise in Tiber EU and ICAST. I have few certifications, as you can see, and I'm author of some open source tools. You can find the open source tool on my GitHub. This is my friend Kyprianos. Unfortunately, he can't be here today with us. We did together the research, and he's a CISO in a company based in Greece. He's a co-founder of the Offensive X conference. He has experience in adversary simulation, emulation. He has few certification as well. Also, he has some CVs, and you can find him with this handle on Twitter. So today, I will present a research that we did before 1 year about C2 automation. And I will tell you a story how one day we wake up and we wake up from a nightmare and the service that we used to implement in our engagements stopped to work because stopped to work because Microsoft retired it. We'll start to explain about what is domain fronting. We'll explain some C2 infrastructure standards. We'll focus to a specific technology, Cloudflare Workers. We'll show some setup steps, and after that, we will introduce a tool that an open source tool that we created, and some detections as well. Okay, domain fronting. Okay, domain fronting, it's a network technique that you cover your server behind a legitimate service. What I mean, think about to have a legitimate service of Microsoft, and you can hide your domain behind it. So the client, the victim, can see only the requests that you do are going or coming from Microsoft. This would be a great idea. We used to use this infrastructure, and everything was like a paradise. Okay, but one day Microsoft decided, unfortunately, to retire this service. So we couldn't use anymore Azure CDN from Edgio. And the problem, me and my friends, were like this picture. We didn't know what to use. The projects were coming back to back. We didn't have something good as infrastructure, so we didn't have the plan B. So this day, uh, learned me one big lesson. To have in your operations always plan B, always. For example, now we'll present something about infrastructure with Cloudflare Workers. But however, I have plan B and plan C because you don't know what will happen in the future. This game is like a cat and mouse, and always you need to be updated and ready for anything. Before continue our story, let's clarify the four C2 infrastructure standards. This is my personal opinion according to my research, And these four things, for me, it's like the Bible of C2 infrastructure. Let's take one by one. We want low cost of our or affordable pricing, OPSEC, operation security. We'll explain this later. Protected team server and setup time. Let's see one by one. About the about the first thing, we need, as we said, something like a low cost or affordable price. If you build a server, a normal server, of course, it's more expensive than a serverless service. So we prefer, of course, a serverless service because it's more cheap. Sometimes uh, it's free. The second part is about operational security. If you are not familiar what is operational security or OPSEC, it's about hiding what you are doing so defenders don't notice you, like avoid patterns, covering your tracks, and making your activity look normal. So because I'm from Greece, I think the first people they put this term in the game, OPSEC, were the ancient Greeks with Trojan horse, as you can see in the picture. So in Greece, we know some things about operational security by our nature. So what I mean in this part about operational security, let's make it more, or let's give a more practical example. For example, if we have a client and from our external reconnaissance, we see that they use specific technologies. For example, a Fastly technology, for example, Azure, for example, Google. In order to do blend-in with our internal traffic, obviously it's a best idea to try to use something relative with their technologies. It will be bad idea to use something different. Uh, for example, I will not use Cloudflare when the client use Google because it's more easy to find you. If you use the same technologies, uh, a lot of times it's difficult to detect you. However, for this part, I need to clarify something. There is no silver bullet. Okay, sometimes I have clients that they use Google and I use the Cloudflare, and Cloudflare work as well. So there is no only one way. That's I want to tell you. The third part is to find a way to protect our team server. Our team server, let's for this example, I use Cobalt Strike. Probably it would be exposed on internet. So we need to find a way how we can avoid any detection. We have a malicious application open public on internet, and of course a lot of threat hunters, public scanners, they can scan our team server and try to find to identify if this is actually C2 team server, a command and control team server or not. We'll explain later different techniques that we can avoid these detections. Okay, and the fourth part is the setup time. Have you ever listened the phrase time is equal to money? I'm sure you have. But I will add this thing: time is equal to money is equal to energy. What I mean, I will give you an example. When I was back in Greece, my previous company, we used to use SC2 infrastructure very weird. We set up the team server offline, not exposed from internet, but it was inside the ESXi. And then we, via WireGuard VPN tunneling, we tried to communicate to create a private tunnel between the team server to expose redirector on internet. So all of this thing costed a lot of energy. So after the setup, all the team was exhausted only for the setup. So my advice is to have something very quick to set up the infrastructure and don't spend your energy there and keep it for the next more critical phases like the initial access, the phishing campaign, the post exploitation, etc., etc. So, as I said, one day we wake up and the Azure CDN Edgio stopped working. So we decide with my friend Kiprianos to do a research for alternative C2 infrastructures. And we found Cloudflare. Okay. What is Cloudflare? This is a serverless computing platform which allows to developers to run different kind of codes like JavaScript, TypeScript, Python on a global network and data center. So you can build and manage your workers, this technology, via a command line tool named Wrangler. This is a picture high level how Cloudflare Worker communicates in high level. And let's see how we can use it for a C2 infrastructure. First of all, let's see a little in depth how is the anatomy of the Cloudflare Worker. So Cloudflare Worker works with two different files, wrangler.jsonc and index.js. So these files communicate each other and then forwards all the traffic back to our C2 server. We'll explain later more detail about all of these files. Also, we need to mention something. Cloudflare Workers, there is a free version and paid version. The free version limits you to 100,000 requests per day, which are very, which are enough for every day. Also, the paid version costs $20 or $30, if I remember correctly. Give you the ability to use custom domains, and also you can use unlimited requests. Personally, I use the free version. So this is the anatomy of worker URL. As you can see, we have the worker project name, a subdomain that we want to choose, and the extension workers.dev. Okay. From the other picture, you can see the dashboard of workers on Cloudflare. You can create in free version as many as you want projects, subdomains you want. I don't think it has any limitation. Honestly, my record is 6 redirectors concurrently. And also you can choose any subdomain you want if it's available, of course, in the free version. So let's go to the part of wrangler.jsonc. This is file that contains all the variables. And what is the most interesting of this file? As you can see from this, from the content of this file, I have set up my team server and my redirector. All of this information is not public exposed on internet, so someone can't find this information. So our team server URL, it's always hidden inside to this file. So what's the meaning of the redirector? It's we want something to cover our team server. Because if we use immediately the team server, it's more easier to detect us. So all of this information is private. Index.js, as I said, workers works with 3 types of languages, JavaScript, TypeScript, and Python. Personally, I prefer JavaScript. So this file actually what it's doing, it's a custom code that we wrote. It takes the incoming request and forwards the post and get request back to the team server. As we saw, before, let's go back. This is the anatomy, as I said. The Wrangler.jsonc has the specific variables. The variables, the worker calls this file to take the variables and use the code that we wrote to forward the requests, the correct request in our team server. So let's create step by step a redirector together. If you are a user on Linux, you can use this command. On Mac OS, you can use this command. And then for only the first time, you need to do interactive login with your terminal. Then a new browser page will open up and you need to press the allow. And then you will see on your terminal, you have successfully authenticated with Cloudflare Wrangler. The next step is to create a Cloudflare worker. With this command, we can easily create. And as you can see, it's 7 questions. Yeah, 7 questions that you need to answer. For example, the name of the worker that you want, which language you want, if you want a specific example project. For example, in this example, I use Hello World worker example. If you want a Git version to see any change that to track any change that you do, and of course, to deploy the application. When you press enter and you answer to these questions, a new, excuse me, a new worker will create and it will be available for you in your specific subdomain that you choose. For this example, we use nickburd.worksdev and our project is AWS-API-cloud. Automatically, a new page will open. And of course, because we choose the example hello world, will open and we can see that our redirector works. We set up very quickly our redirector in 1 minute, I think. So the next step is to take the previous code that we present, the wrangler.jsonc and index.js, and of course, to copy paste in the relative files, and then to do npm exec wrangler deploy, and to update our deploy. So in 1 minute, we create the redirector. Setup time, done. Serverless, done. Let's create our team server. For this example, I use the Azure environment, and I will try to create Azure VM with open ports 443, 80, and 22. I will give any DNS name that I want because the team server is not exposed to the client. The redirector covers the team server, so it doesn't matter so much the name of the DNS. The reason that we want the DNS because we want to create SSL certificate, and for compatibility issues with Cloudflare, we want SSL and the domain. So let's create a let's encrypt SSL certificate with these commands, a standard alone for this example. As you can see from this picture, we have very quickly our SSL certificates. And then we'll try to package these PEM files to PKCS12 file. And then we'll try to convert this file to .store, keystore, Java keystore file format because it's acceptable for our command and control Cobalt Strike. What else we want for the team server? We want a malleable profile. If you are not familiar what is a malleable profile, think about it's a configuration file that you can control the behavior of the C2 server, and of course the implant, the malware behavior. For example, in this file, we will create something like the traffic that we want to see behind the scenes, any get and post request. If you are not familiar with this, I will tell you something. What is a C2 server? Okay, a C2 server, it's a malicious application. If you see behind the scene what's happening, every command that you press, any communication with implant back to the team server, it's like a get and post request. So it's a malicious web application. So in the malware profile, sometimes I have seen that I had the conflicts with, especially with proxies. You know, in an internal network, there is not only the EDR that's all the people focus. There are a lot of things that you need to be careful. One of these things is the proxy and the DNS security tools of internal organization. So I'll tell you a story. One time, I had a project back in Greece, and we create a super cool implant. Okay, we bypass the EDR, we fish we fish the targets, EDR bypass, no any detections, but the callback didn't come back, and the reason is because it's stuck on proxy. Proxy detect the traffic like EC2 traffic. Why? Because me and my friend we were used some common malleable profiles, and because of the patterns of the common malleable profiles are very detectable. So we decide and we found this project. It's from Thread Express. Shout out to Joe Vest. So this project is a Python project that's give you the ability to create random and unique malleable profiles. So every time your malleable profile, your traffic is unique. So no one proxy can stop you for detection. Because the original author stopped to maintain this project, I started to modify this repo with the new additions, the new settings that Cobalt Strike has released so far. And you can free to use on my GitHub to create random and unique malleable profiles. If we run this project, you will see that we create a random malleable profile. We need to set up a Python virtual environment. And then, of course, we just generate a malleable profile. After that, if you want to change things inside the malleable file, it's up to you. So, of course, you will do some configurations on that. And the most important thing, we need to set up our keystore, Java keystore file, and the password that we gave when we converting the PKCS 12 SSL certificate to Java keystore in order to be compatible with Cobalt Strike, and also to have the keystore in the same repository with the team server and the malleable profile. So far, we have set up our redirector, we have set up our team server, we used Cloudflare, which is very cheap, free. And what else? We did it very quickly. We need to make them to work each other, to combine them. So we'll set up HTTPS listener, okay? And then we just try to see if our beacon works. And we see that the beacon works. Okay. Until now, we cover almost all the steps, but we missed one thing. Let's go back to 4 standards of EC2 infrastructure. What we said, low cost, we use Cloudflare. Okay, free, we don't pay money. We cover this. We use OPSEC. Let's suppose to our example, our client uses Cloudflare, so we use OPSEC. Okay. And we cover setup time. But we miss the protected team server. Our team server is public exposure on internet, which I said in the beginning, a lot of threat hunters, bad people, public scanners, they will try to detect our team server. We need to find a way how to protect this. Let's go in front. Okay. So I said, as Jack Sparrow says, we missed one thing to protect our team server. Sorry. Okay. At this point, I want to shout out to Kyle Avery from Outflank for all the guidances that he gave me. So this idea, practically, I borrowed this idea from Kyle. What he said, I use a custom headers and I prefer to use another web service to filter all the incoming requests. Practically, what does it mean that? Let's suppose this is our infrastructure. Our beacon, our implant will communicate back to us. Okay. We have the targets, and from one edge and to other edge, we have the Cobalt Strike. But intermediate, we see that I put it Nginx. Okay, Nginx, of course, is a web service. Why I need another one web service? I have one web port open, the HTTPS 443 open from Cobalt Strike. I will try to change one thing. I will set up the Nginx and I will put the Nginx to work in 443. And after that, I will try to configure Cobalt Strike to bind to 443, but expose to listening in 8443 to another port. In this way, all the coming requests that they will coming, they will go first to Nginx and then to Cobalt Strike. With the Nginx configuration, I will set up a if condition and say, if the incoming request has this custom header, it's a header and custom value that I know, and because I will put this information to our malign profile, so my beacon will have always this header, please let it to pass. If not, access denied. I think it's very simple. Sometimes the most simple things can solve the biggest problems. Let's configure our wrangler.jsonc. What I will do, if you remember the first example, I have only a team server and redirector values. Now, I will put my header value. For this example, I will put the super secret value. Okay. In a real engagement, don't use this. So, as I said, the wrangler.jsonc keeps private all the values and not exposed to anyone. So everything are private, as you can see. And the next part, I will try to reconfigure, to config my index.json, sorry, the .javascript, with adding the name of the custom header. Okay, the custom header will be public exposed. We don't have problem for this. And of course, I check that if it's we have the specific header value, we'll take it the value from wrangler.jsonc. And if is the post request or get request, please forward, unless please show the error authentication failure. So any scanner, any threat hunter, that it will try to check my Cloudflare, it will be take this error authentication failure. And again, from Nginx, we need to create another Let's Encrypt, but this one will be specified as Nginx type. And last but not least, we need to configure the Nginx configuration file, as I said, with a if condition. As you can see from the picture, if it has this, the custom header has this value, if the incoming request has this custom header and has this value, please proceed and pass all the traffic to 8443, which is our Cobalt Strike HTTPS listener, or access denied. Let's configure our HTTPS listener, as you can see, but at this time, as I said, we'll bind to 8443. And the reason that we are doing this is because if we open the Cobalt Strike in the same port as Nginx, the port it's already in use and will not let us. And again, we'll see that the beacon works and we have all the infrastructure ready. So in this way, we created all the infrastructure and we follow the 4 standards of C2 infrastructure. For this reason, okay, we created, me and Kyprianos, shout out to all guys that helped to this tool and committed. So we created a tool named Skyfall Pack Automation to make all this process pretty easy with 2 clicks. Skyfall Automation Pack is version 1.2. It has different languages like Golang, Terraform, Ansible, and Bash scripting. Also, it is integrated with Cobalt Strike, and sent out to Juan Martinez Moreno, who help to set up Outflag to do the integration and all implementation with Outflag Stage 1 C2. How it works, Skyfall. As I said, it has different varieties of languages. It has Terraform, Bash, Ansible, and Golang. The 4 packages, as you can see from the names, you can understand which package for Terraform, which package from Ansible. The script pack is Bash script, and workers pack, it's a Golang pack. The script pack, the only thing that you need to focus to this is 2 packs, the script pack and worker pack. The script pack contains 2 Bash scripts, the setup.sh and the run_ansible.sh. So the first one is to set up your team server in very quickly. And the second one is to configure anything you want. And also in the new version, the configuration supports also generation of a malleable profile. So you don't need even to git clone the project to set up the Python virtual environment. It's everything automatically. And of course, workers pack contains the worker, the workerman. It's a Go file which generates the index and the index, the JavaScript index, and the wrangler.jsonc. Let's see in action. As I said, setup is for the team server. So setup, what we need to set up a team server, Azure VM on Azure, we want the location. It supports almost all the locations. North Europe is US, is US2. A username that we will use for our SSH. Resource group, we use anything we want. The name of SSH key that we want to generate. A DNS name, as we said, in order to communicate with Cloudflare without conflicts. And the VM size. It supports 3 sizes, if I remember correctly, standard underscore B1, B1MS, and B2S. I think the most cheapest is the standard B1MS. When we run this process, in a few minutes, not even a few, I think it's in 1 minute, you will have ready a VM on Azure, and all the details, if you want to connect, are there on Terraform output file. The next part is to configure our team server. First of all, we need to create a Java key store. We need to give the file name that we want, a password, and also custom header, and the custom value. We'll press this, and in 3 minutes or 2 minutes, we'll set up everything. The configuration of Nginx, the package that you want. We added extra packages if you want to have proxy chains, Python virtual environments, Dockerized if you want to integrate with Outflank stage 1 C2, um, anything you want. The only thing that doesn't have the C2, you need to download and put the C2 alone, which is 1 minute work. And the last thing is Workerman. Workerman is a Go tool. What is doing Workerman? It generates the specific files that you want because, of course, we don't want to remember code and all of these things. And of course, the code that generates, it's not static, it's polymorphic, some parts, of course, for some static detections on the page. And you take the content of this file of these files. Of course, you use npm create Cloudflare. You answer to 7-8 questions that it has. In 1 minute, you have the redirector, and you copy paste the content of these files. And you have very quickly all your infrastructure without spending any of your energy, saving your time, keeping safe your team server, not spend affordable price of redirector, of course, and last but not least, operation security. About the detections, of course, I'm not a defense guy, but as my friend Leonidas Saousis says, we should present we should present offensive security topics, but we should give some blue team or defense advices. I will try my best. Of course, if you have any other idea, if anyone is more experienced in blue teaming, of course, I'm free to open to tell me new ideas. The one easy thing as implementation is check URI patterns. A lot of times attacker uses common words like update, status, CMD, get. So this is not as detection as itself by itself, but it can be useful if you combine with other type of detections. Of course, the intervals of the communication of the beacon, how much the beacon communicates back. If you see every 10 minutes the same request, it's something suspicious. I know that it's not so easy when you're in a corporate network, when especially in working hours, when everyone uses their computers, but it's an option. Of course, you can create, the most useful, I think, is the third part. Of course, you can create, if you don't use Cloudflare, you can ban workers.dev. This is a specific characteristic of this technology. And the last part is to identify any connections to them, if it's suspicious or not, for a non-browser processes. Some references that some people, they try to do this research before us, and it was very helpful for us to follow their ideas in our research. Shout out to everyone. And that's it. I was Nikos Vourdas. Thank you. I hope you like it.
Awesome. This is a really interesting presentation, really cool. I'm not seeing any questions, but I think the chat and Discord is also kind of reflecting the same thoughts. This is a great talk. I just recently learned about Cloudflare Workers, so it's cool seeing how you applied that.
Thank you, man. You can find it You can find it. Give me 1 second. Every tool that's you can see my screen again.
Oh, we can see your screen.
You can see my screen.
Yeah, you're good.
Okay, sorry. So you can find all the tools here in this GitHub. You can find the Skyfall. I have another tools. Feel free to use. Feel free to do commits, anything you want. That's it.
Awesome. There is a question. El Ray says in chat, I haven't dug into the code yet, of course, but how do you handle the Terraform state?
How I handle the Terraform state, about
Yes.
how it works. The Terraform part, what it's doing, it creates a Ubuntu VM on Azure.
Mm-hmm.
Okay, you need first to do AZ to use AZ Azure CLI. Okay, and another one from Discord did the question, by the way. So you log in from your terminal with Azure CLI, and the Terraform, what it's doing, it tries to create a specific VM with a specific characteristic, as I show in an example, the location, the name, the resource name, the Azure, the VM. So the VM, what else? The SSH key, the username that you want, and create a Voodoo machine very quickly. Some people will ask, okay, what will happen if I use the tool and my friend use the tool? And unfortunately, for any reason, we use the same DNS name, because the DNS name, if not public available, you can use it. So what is doing Skyfall? It gives some random characters after the name that you choose in order to avoid this conflict. So every time the DNS name will be available.
Awesome.
Okay,
Great.
another one question from Discord. Do you take into account shared storage to allow for multiple people to deploy? What does mean? What he wants to tell? I didn't understand.
I think you actually answered I guess, at a high level, that question with what you just said
Okay.
before. Yeah.
So any other question?
Yeah, he just asked another question. He said, have you thought about using Ansible Dynamic Inventory for automating the build? Um, and I guess
Look,
those are.
guys, I will answer you. First of all, before this project, I wasn't so experienced in Terraform in Ansible. This is my first project that I created with Ansible and Terraform. Okay, because I wanted to learn, I thought this is a good idea, all of this that I presented, and I wanted to make more automated. So I searched on Google or ChatGPT how I can create, how I can do all of these automations. And I found that in order to set up a VM on Azure, I need the Terraform. And if you want to do configurations remotely, you need to use Ansible. I'm not an Ansible expert. Okay, if you see the code actually that I use, it's very simple. It's not something crazy because I'm a senior offense security consultant. I do pen tests. I'm not so much developer. And after this project, I haven't used Ansible and Terraform again, to be honest. Uh, so I don't know if I can answer to any technical question about Ansible. If you see my code, I can show you the code. You can see my screen again.
Yeah, you're good.
If you go here to Ansible pack, you will see that it has the inventory and the roles. Okay. And inside the roles in system, it's everything that is doing. I mean, all the updates, the Let's Encrypt install, to create the malleable profiles. It's happening in this place. Of course, we have the main, and then they include all the tasks. So it's pretty easy, Ansible. It's not something like very, very crazy uh, as implementation. But of course, if you have better ideas for the tool, it's free, it's open source. I will be more than happy to do your commits and make this tool better and better and better.
That's awesome. Yeah, I think we do appreciate you sharing this because I think it is in a place where the idea is out. It's been proven. You showed that you can use it in engagements. So I think the people who have ideas, I'm sure that they will be forking and providing some updates to your code to make it even better.
Yeah, nice. Thank you very much.
Awesome.
See you again, and thank you again for the invitation and you accept me my CFP. Bye bye.
Yes.
Have a
Bye.
good one, guys.
You too. Awesome. That was a great talk. We thank Nikos for his time. So if you're still interested, I believe Nikos will probably drop some more information in chat, in Discord, or you could just use the links that you saw in the presentation. We're going to kick off another talk. We're going to pack it right in about 10 minutes, and then we'll have a pretty big break between this next talk and the last 3 talks. So don't go anywhere. We'll be right back, and thank you for participating. Without further ado, we're going to kick off the next talk. It's called Embedded AI and Malware, a New Frontier in Cyber Threats. This talk is recorded. There's a presentation provided. If anyone wants it, we'll drop it in chat. But without further ado, here's Ghost Pepper's presentation.
Be I'll try to this is going to be a little technical discussion because we're going to talk about what is malware and what it looks like inside a malware in a traditional sense, and then how the adversaries can leverage AI inside a malware. Like, we have seen a lot of adversaries already using AI, but they are using outside of malware and not inside a malware. So this is more of a security research, which has been done by CISO team at Pearson, wherein we are trying to leverage AI inside a malware and see, how you can actually adversaries can actually bypass the defenses, evade our different defensive in depth guardrails, and no, it's going to be a little technical, but as I mentioned earlier, please do not use. I'll try to reiterate what Tori mentioned earlier, that please do not use uh, anything. It's just a disclaimer. Don't use it because this is going to actually tell you how to create one malware. But it's more on the security research side to improve our defenses rather than use for malicious purposes, right? So that's the reason. So having said that, so this is the agenda here. What is malware? How do adversaries use malware? Then how we'll have a quick look into inside a malware and then see for comparison how AI can be used inside a malware, right? So that's the thing. So moving on to the next one. So is there a digital gremlin in my laptop, right? This is the first thing what comes to my mind. Like anybody who actually using a system and your system starts behaving odd, like either it's very slow or you have a lot of pop-ups coming in, and then you start doubting, do I have a virus or do I have something which is malicious, which is actually kind of doing all kind of odd things which you never or which you never faced it in the past. So so when you start suspecting malware, the question comes up in, okay, what is a malware? Malware is nothing but if anything which is malicious, aware, right? Like it could be a software, it could be hardware or anywhere. When it's used for malicious purposes, it's called as a malware. And it has different terminologies over a period of time. There's a long history to it. So it's called viruses and worms, trojans, ransomware, spyware, and there could be new terminologies also coming in. But the thing is, there are a little bit of nuances between these terms, but basically they are all malicious, right? They're small pieces of code, or it could even be hardware, which is being used for malicious purposes, right? So another term I would like to introduce here is a command and control, which is called a C2. So this I'll show to you what actually in a little more detail in the next slide. But this is nothing but it very clearly says that it's an infrastructure used by criminals to communicate with the control malware infected devices. That means, let's say you click on a link and you download a software, install a software, and apparently it is malicious. And then what it does is it gives a control back to the attacker or whoever is actually managing that particular malware. And once you give the control to the attacker, then that is what is called as command and control. That means the malicious user or the attacker can actually control your system and do whatever they want, right? And there are different communication channels which takes place. That means when some malicious software is installed like a malware, then what happens is it can be communicated back to the attacker using DNS tunneling, HTTP, web shells. There are so many channels out there, even social media channels and emails that attackers use today to communicate with your infected system. Okay. Okay. Going on to the next slide. So this is the don't get bogged down by the complexity of this diagram, but it's very simple actually. So this part what you see here is actually your laptop, let's say like your laptop or server or whatever, right? So where your all your softwares are installed, where you actually work day in and day out, installs softwares, or you use some application, anything, right? Whatever you do, this is your laptop, and this is outside of the of your system. That means you as a user, you get an Outlook which is running in the system, and then it could be phishing mail, and this can be divided into two parts. One is the user land and it's called as kernel land. That means The kernel land is nothing but your operating system, which has got like full control. And user land is where you have limited privileges to do things on your system, like delete a file, open a file, read and edit file, right? And you don't really manage a lot of things what the operating system does. So which is why it has been divided into uh, two segments. Let me put it that way. Now, we also know that in Pearson, what we are doing is we are installing CrowdStrike agents, which is your EDR as a sensor, or you could also have Microsoft Defender as an antivirus system, so, or software. And the communication what happens is between, there are some DLLs, Windows DLLs, which actually communicates between what you do and what the operating system does. That means, you let's say you open a file, that means, there's something called as kernel DLL, which is running on a system, Windows system, and it actually calls operating system saying that, okay, all right, this is what the user is trying to do. He's trying to create a file, so do this for me. And it everything, the operating system takes that information and does the relevant job, and you get it and get the response back, right? So it happens so seamlessly and so fast that you don't even realize. But this is in just what actually happens behind the scenes. Now let's say as a user, you get a phishing mail in the Outlook. Thanks to our SOC team, they keep sending phishing mails so many times. But let's say you get a real one, and it has got a malware in it. So I have depicted here as a bug here, right? It's a malware. Now you, let's say, unintentionally you deploy it on your system. Now what happens is, this particular malware calls back the attacker. Once it is deployed by you explicitly, it calls back the attacker. How does it call back? Either through one of these channels, what I mentioned earlier: DNS tunneling, HTTP web shells, email, anything, right? SSH also. So it calls back the attacker. That means it's kind of normally what happen is, if you are a user here, and if you're trying to go into server, you will be SSH into the server, right? This is having the other way. It's a reverse communication. That means the malware is trying to contact by the attacker and giving the control to the attacker. So this is called as a C2 channel. That is your command and control. So once the malware contacts the attacker and gives the shell, that means basically access to your system, then the attacker can read your files, see your files, change files, and do whatever you could do. With all the privileges what you have, the attacker will also have, and you may not even know that the attacker is actually using your system, right? So this is the basic. This is a very high level and very simple way of depicting what actually happens when somebody deploys a malware. Now, let's go inside a malware. So what actually what the attacker would have done is, there's a bit of a process here. Like what happens is, they would have infected some file, and and the malware is there are two components to a malware. One is called as a dropper, and other is a payload. So dropper is nothing but a benign software, which is like container, right? It's like a container. It's just benign, it doesn't do anything. It's just like communicating back to the attacker, or doing some jobs locally. But the payload is the most dangerous one, which actually does the damage to your systems. That means it could do a privilege escalation, it could do a lateral movement, it could do exfiltration. That means extracting your data, and or even in case of ransom, it may start encrypting, right? So that payload is actually designed by the attacker, and and it is embedded in that malware, and it is, when you run it, this payload gets run, and this is inside of a malware. That means this bug which I showed you earlier, this one, the inside of that, it'll be like, for people who may be familiar with the terminology of the development, it'll create a process, it'll allocate a memory, then it'll write the payload to the memory, it'll open the process first, then it will allocate a memory, a separate memory inside the process, and then it will write the payload into the memory, and then it will execute it. It'll do a create thread or load library. There's so many ways of executing that payload. So basically what this malware is doing is actually executing this payload, and and resulting in what you see when your system gets infected. Now, this is a classic malware. Now, let's see. So when we come to AI, how we use in the AI is very similar. The difference is that the process is still the same. The difference is that this payload is something which actually gets identified today by Defender, CrowdStrike, and EDR agents and all, right? So all these payloads are some of the adversaries or attackers use standard payloads, which comes, which others have been using it. Other APT, other attackers are using it, or they may create their own everything. But the thing is, they're all in hexadecimal code and embedded somewhere. They could be encrypted, they could be decrypted, and what the malware does is it will decrypt this payload and then it will execute it, right? So that's what it does in a classic malware. But in AI, there is a very interesting way of evading those defenses. What it does is, in this AI, all this payload, which is doing the distress things, is actually coded as an English language. So that's a interesting thing. So if you see here, each of these payload is are actually nothing but randomly generated English words. So any system which actually will try to look into the malware, they'll see that, okay, yeah, this is all English language. There's nothing harmful about this, and even if people are actually trying to reverse engineer and look into it, all the security engineers, so they'll say, oh, this is all English language, there's nothing wrong about it, so it is all benign, right? But actually what's actually happening is these English words are actually being translated into the vector embeddings in AI. So in AI, what happens is, you generate a payload. I'll show you how to do that. You generate a payload which generates the random words against the payload, and it will generate all its numbers. And this numbers, this is nothing but a vector database. So vector embeddings. So this vector embeddings is what is um, sent along with the malware. So, and what the malware does is it uses AI to get back the payload from these numbers and execute it. So for instance, here also, if you see, this is the English word and this is the payload. So all these payloads have been correlated here. This is done by the attacker on the attacking side, right? This is not happening inside the malware, but this is having outside a malware where the attacker is actually converting the English words into or the payload into English words, respectively words, and then converting it into a vector DB, which is these numbers. So if any, and this is shipped along with the malware. Now, any reverse engineer would look into it and say, oh, these are all numbers and then this is all English languages. Why do I even care? I mean, it looks all benign, right? But that's not the case, because behind the scenes, it's all actual hexadecimal codes, which is actually a dangerous payload. Now, this is how the malware is actually using. And then when the malware actually gets executed, then what it does is it actually uses the AI engine to convert these numbers into respective payloads and run it. Okay. So now I'll do a quick demo here and show it to you. I mean, it's a recorded demo, so I'll just showcase here. So this is your attacker machine, and this is your victim's machine. Let me see the time check. I think we have time. Okay, all right.
Yes,
So
yes, you do.
okay, thank you. And this is the defender which is switched on. That means it's actually on, and the real-time production, right? So it's already on. If I execute the payload which I showed you earlier, which is like an hexadecimal code, the defender would actually immediately say that there is a virus in it and it will not let you execute it. But because it's been the same payload has actually been um, converted into vector embeddings, so and which uses the malware uses the AI engine and executes it, right? So to depict here, this is your command and control, this is your attacker's machine, and this is your the victim's machine. That means whoever is executing the malware. So let's go in there. So what I'm doing here is, this is actually starting it's listening to some traffic. That means, as I told you, the C2 channel, that means the malware once is executed, it will communicate back to the attacker's machine, right? So I'm listening here. So I'm waiting for the malware to communicate back to me from a different machine where the malware is running. So I'll execute the malware here on the right side. And I will, I have named it as a Byte Viper, some interesting name, and connecting device. So I'll just fast forward it so that, we just don't have to wait. And let's go. Yeah, it's doing its due diligence. And then let's see. Yeah, it's fetching the payload now. So if it's fetching the payload, and then, and okay, see, the payload got executed. and that means now the controller actually got. Okay, sorry, I think I need to move this here. Um, yeah, so the no, I don't know how to pause this. Yeah, there you go. So if you see here, the attacker got the control to this system. That means now the attacker can actually, this is the command prompt of this particular system. That means this particular attacker can actually browse through the system and see what is in the folders, copy files, do whatever you want, right? So now the attacker has complete control of your system, and the user would not even know. And the thing is, it has even evaded the Microsoft Defense System. So even if this is on, because the payload was so, it was actually just um, you know uh, decoyed as English words. The defender could not even find out that, okay, this is actually a malicious payload inside inside a piece of software, right? So this is the simple demo of how AI can be leveraged to um, execute malicious payloads by adversaries. Now here I'll show you a bit of the code here. So we have, this is the typical, it's a C code. So don't get bogged down by it. I'll explain to you. So very simple. The thing is, this is the payload, the normal payload, right? The traditional classic malware. So basically this is the payload, and then it opens a process, and then it gets a process, and then it actually allocates the memory, and then it actually executes this. There are some yeah, assembly code and all, but don't worry about that. But eventually what happens is this particular payload get executed, and your malware is deployed. But because this is a plain payload, may not be encrypted, decrypted, or may not be obfuscated, let me put it that way. So the defenders and CrowdStrike, they can find out very easy, unless it's a very fresh payload like a 0-day, right? Unless it's a 0-day payload, you will not be able to find it out, or you'll be able to find it out. Now, normally attackers, what they do is, they encrypt it, and decrypt it only when it actually needs to be executed. But the problem with that is there's something called as entropy. So the entropy of the file increases so much that any antivirus, whether it's the EDR or antivirus software, will start doubting that, okay, if the entropy is high, it's normally because it's encrypted. That means somebody doesn't want me to see what's actually happening behind the scenes. So it'll get flagged anyway. So, but in case of this one, the AI based, what happens here is, this is the same thing, but here instead of using those payload or encryption, there's no encryption, there's no obfuscation. That means the entropy of the file is also stays very low, and it's all English words here. And same thing, what it does is connects to the AI, fetches the payload what I showed in the demo, and then it creates a thread, and the payload gets executed. And if you see here, this is the place where the attacker actually generates the payload. Basically, I can actually show you in another location actually. Yeah, I can show you here. So this is the Colab. So the attacker actually created the data set, enter the values in here, and then the attacker would actually create a data, the vector embeddings, um, and save it as a pickle file. So pickle file is what I'm using right now. So pickle file is saved as a pickle file, and that pickle file is shipped along with the malware. That means this particular piece of code is the malware, and whatever is generated from the payload generator gets shipped with the malware. And what gets shipped is only this, the uh, only this part. That means, let me show it to you. This part, the numbers. So only the number part actually get shipped, and then when the malware is actually running, then it will actually go to the AI engine. This is the AI engine, which converts those English words into respective opcodes. That means the assembly hexadecimal codes, and gets executed by after reversing everything. It gets executed, like for instance here it's doing all those things. and then it's same thing. It's the same classical way of allocating the memory, writing the payload, and executing in the thread. Right. That's what happens out here. Now, one thing is that once this, let's say, you create this thing, the embeddings, even the attacker themselves will not be able to see what is the actual value of that unless they use the AI engine. That means if you lose this embeddings file, let's say you use the source of what those English words were and what was it converted to, even the attacker themselves will not know what actually those the vector embeddings actually mean, because you need to have some kind of correlation to get that, and and the only thing that can do the correlation is the AI engine. So even the attacker cannot find out. So let alone other security researchers who are not even are the author of those particular malware, right? So I think we are up on time. I think, and I on time I completed what I had to show. This is a little piece of research we are doing at CISO, and ensuring that we are proactive in trying to leverage technologies to ensure our defenses are strong, and we test it out pretty often. And time and again we try to see if our defenses are up to the mark, and if there's a gap, then we try to fill it up. Thank you.
Awesome. So that was a great presentation. I just recently created a speakers artifacts channel. If you are interested in that presentation or any of the presentations that happened before, you can find the speakers' GitHubs, their projects, their presentations in that channel. I think we're currently having technical difficulties with our Matrix bridge, so we'll post that in Matrix as well if you are not on Discord. So yeah, we are going to have a 2.5 hour break. Now we're gonna have our next talk at 2:30, so quite a big break. If you are not in Discord, you can just go to carolina.com/comms, or just go to CarolinaCon. Sorry, not .com. CarolinaCon.org. Go to CarolinaCon.org. You'll find the comms page, and you can join Discord Matrix from there. Let me see if I have a slide for that. So, yeah, join us there. Find more information. We'll be back at 2:30 to kick off the next couple of talks. We also have a CTF going, so if you aren't participating in the CTF, the prize is going to be an A1 mini for the winning team, a single A1 mini for the winning team, and some swag for top 3 teams. So we'll be back, but the stream will keep going. So thanks for joining us. We'll see you soon.
and then go into that stealth level, because once a site goes down and once a server goes down, yes, even though it's coming back up, it takes a while, and not all the processes are going to start right away, right? It's a time reset. But if I start my self tac, I can kind of interrupt that reset and kind of overload the system a little bit more with those low level attacks. Okay. So impact on defenders, right? So you have a core service there, then you should have defense in depth, right? So you have your infrastructure, but you have things built around it to mitigate threats as they come into your network. So think of it EDRs, firewalls, some form of SIM, a SOAR, might be a third party scrubbing or a WAF or something like that. So I'm trying to penetrate as much as I can to impact your business, right? If I can disrupt your business, think of it from a financial standpoint. If I'm a bank and my apps or my website keeps getting DDoS or affected, and people can't go pay their bills or check their banking account or do transactions, that becomes a reputation damage to the company. People are going to be like, well, I'm not going to stay with Wallace Bank because every time I need something, their site's always down. So I'm going to go to this bank instead. So you're going to lose customers that way. There's also regulatory requirements. So reporting and also potential fines from governmental agencies. And then, like I said, you're trying to do that short term, traditionally short term defending is okay. I block the malicious IPs coming in. I geo block where they're coming from, or use GDP anycast or something like that to mitigate that attack. But as time goes on, those blocked IPs or whatnot kind of get unblocked as throughout it. So yeah, you mitigate it for one attack, but a week later they're no longer blocking that stuff because it's no longer a threat, but they come back towards you. And then operation dynamic IP rotating is what I call whack-a-mole. Is that okay? You got this part of the attack contained or mitigated. Well, they change either their vectors or their IPs. They spoof their IPs, and then kind of making the defenders play catch up to what they just changed. They're always kind of playing whack-a-mole with these with the DDoSers. So that's kind of like the baseline of what DDoS is. So, like I said, traditionally we play whack-a-bot, I guess you would say. DDoS pops up here, you whack it, you mitigate it, it goes away, but then no one pops up. But you forget about that first one that pops up, and then like on the right, we call this a pop-up target. In the military, you shoot in your range, and you have these pop-up targets from 50 meters all the way to 300 meters. Well, I engage the 50 meter, it goes down, the 300 pops up. Well, I forget about that 50, but it's going to pop up again. But you kind of forgot about because you're engaging other threats on your network. So that's kind of the reason I had to look at this from a different methodology, is looking from historical basis, not just singular events, but what events tied together, what is the commonality, and can we start building out these infrastructures and their capability. So now we'll kind of go into this methodology that I created that we're using here, but kind of give you an idea of trying to get out of that singular threat mind state and into more of a holistic thought process. So, like I said, why clustering? It's essential because malicious actors, like, they reuse their infrastructure across their campaigns. Not just one not just one target company, but others as well. And being a DDoS mitigation platform, we're able to get a large swath of DDoS data against industry, against regions, against multiple customers. So we can see the commonality between these attacks. And then, like I said, we're trying to identify, the same bots, the same IPs that keep coming up over time. And then by clustering, we can shift from that static indicator of compromise or that one event to more of a behavioral indicators, such as like our IPs rotating, the cadence, What are the common vectors? Are they targeting the same industry? Is this bot mainly going after the financial, or is it indiscriminate? It'll go after anybody. So clustering let us, lets defenders identify the most significant grouping. So you can identify what is the largest botnet that's out there, what is the most capable, most destructive, is a better way of saying it. Puts the most bandwidth, most packets, and they kind of help with your mitigation. But also, this can help feed takedowns. So there's a company called Shadow Server, who it's a nonprofit that people submit IOCs to, that they'll go in and they'll tell people, hey, you got compromised um, systems within your network that are causing this issue. Can you go clean them up? So it's kind of hoping that we can kind of use this to help clean up the internet a little bit. So kind of where we start from. So like I said, I'm using our DigiCert's Ultra DDoS Protect services, which is our DDoS mitigation platform. Again, I'm not trying to sell you anything. I'm not a salesperson. Not doing that. I'm just letting you know where stuff's coming from. So we store those in a ClickHouse database, as well as we have a MySQL databases. So rational databases, which are really helpful to do this correlation. Then we start filtering. I drop all non-public IPs. So your RFC 1918s, your 192s, 168s, your 10.0s, your 172.0s, those that should not be on the internet to begin with. They should be dropped at your router, your home router, if you're natting, or your ISP should be dropping them. So when I see non-public IPs out on the internet, that tells me either two things. One, is a spoofed IP, or two, somebody just downloaded a script and didn't change, didn't alter the script to actually be what it is. They just downloaded it and ran it. And then we start looking at is we had to define what a bot was. So we looked at it. If we see the same IP attacking at least 5 or more of our customers in a given time, we identify that as a bot. So we go from, a couple 100 millions, once through this filtering, maybe down to about 100 million IPs, malicious IPs. So it has to meet our bot criteria, which is 5 or more organizations, and that's a bot. And then we start normalizing, look at the timestamps. We start, looking from the ClickHouse data and the MySQL data by time, by customer, and we start trying to mirror them up. It's not 100% one for one, but it gets us close enough that we're able to start combining these two data sets. Then once we do that, then we take the full attack attributes. That's your bits per second, your packets per second, your vectors, your duration, industry, all this other metadata, and we're kind of combining it all together. Then once we're done with all that, then we restore it into DynamoDB, which I'll go into in a couple of slides, why Dynamo and how it can feed other things. So we kind of start our filtering. Then we actually go through the clustering process. The core process is built around operational realism. Like I said, they're grouped by organization, so that clustering occurs only within the same victim content. So we take it, we do a sort by date, time, and then also by organization. So we look at by time, by organization, that is a potential cluster. So organization A, they might have 30 malicious IPs associated with that attack. That's one cluster. Then B, same thing. We go through the entire data set and we kind of cluster that way. A cluster has to be, in order to fall within a cluster, it has to be plus or minus 5 minutes window that we have, because DDoS is sometimes can be long drawn out. So we look at it from the last observed instance within that DDoS. Is there another event within 5 minutes? Yes. Okay, then it groups it into the same cluster. If not, then it breaks and starts a new cluster. So it goes all the way through. Like I said, it has to be active within the time window. then we merge. I'll get into that in a second, but we do a merge. So we look at it. Um, sorry, we do this initial merge for this day. So it does this initial clustering, finds 100 clusters, right, that meet these criterias. Then it looks at within these 100 clusters, does any cluster have a match of other clusters, at least 50% of IPs, malicious IPs? So if cluster one and cluster five, once it's done, they have at least 50% of the same IPs identified, that get merged into a bigger cluster. That becomes another cluster itself. So it goes through that. Then we have like a daily bot cluster. And then we take that, then we pull historical data that was ran yesterday from the Dynamo. We ingest that. Then we start looking at, okay, our new clusters, looking at our historical clusters, which ones match again at that 50%. And then if they find new clusters, then it merges it into that historical cluster. It takes all the metadata, so the bits per seconds, packet per seconds, the vectors, and all that. It looks at historically is like, okay, let me add this to the average of what this cluster can do. Is there new vectors, new industries, new regions? Yes, then it appends that data. So over time, we're getting more information about these clusters, um, their max, their averages, how long they normally go, what's the max they can go, um, and stuff like that. Then at the final end of the day, we end up with a cluster. Um, each one has a cluster ID. You see there on the right hand side what type of information is um, cataloged and stored. This is useful, like I said, for those the bots takedown. So if we can only focus on 10 botnets, which are the 10 that we should look at trying to take down? We look at the most destructive. Each person might have a different definition of most destructive, but that's the way we can start looking at it. You can also start using this as detection as well, which I'll get into my next slide. Then we also track, this method is persistence. How many days active is this cluster, right? Is this cluster active every day that we're seeing it? Is it on a rotational basis that, okay, we see it one day, it's like 1 in 7, right? This cluster only appears every 7 days. So there's a pattern there. Um, IP churn within the cluster. Does it maintain its IPs at the same time? Is it losing IPs, gaining new IPs? And then how is it growing over time? So where can this help feed, right? Like I said, we stored in a DynamoDB. That's just personal here at Digital the way we did it. So I have 3 different tables. You have cluster analysis, the IPs, and history. So my cluster analysis table maintains the cluster ID and the metadata of it, the size or the average gigabits or bits per second, packet per second, duration, all that information. The IPs themselves are stored in a different table with a ability to do lookup between the two with corresponding cluster IDs. And then we track the history of the IPs moving from cluster to cluster. That way we can see, is this a shared botnet? Do multiple groups use the same botnet infrastructure? Maybe it's compromised multiple times. That's why we kind of track the IP history. But you see there, it can feed a lot of different things: reporting, operational actions, such as bot takedowns, a CTI platform, that's your cyber threat intelligence platform. You can also think as your SIM or your SOAR, ingest back into that. So when you start seeing other attacks, you can look at, have we seen this IP? Oh, yes, it's part of this bot group. This is what it's capable of. So it helps your defenders kind of get ready for what might be coming. And then visualizing dashboards and a bunch of stuff like that. So it's good for reporting to keep people aware of what's going on. Using it to enrich the data set that you already have within your network, stuff like that. Check, see if there's any questions real fast. Okay. So this last part, we'll kind of get into the observation I found, right? So I ran this thing. Actually, I'm still running it every day, but from April to June was my data set. So I did that, and I did some deep analysis on it to find out what trends or some of the insights that we might have seen during this time period. So what we call our key findings, or big rock findings. So we identified over 1,000 different clusters within this time frame, averaging about 3 IPs per. Some, they're very low, maybe 3-4 IPs. But you see there, we have one cluster that has over 58,000 different IP addresses. To us, that identifies some form of a Mirai scale botnet. Mirai was their source code got leaked, I want to say back 2016-ish. Once that source code got leaked, a lot of these groups have taken that, tweaked it, but they're still using that foundational code to do these. So there's a lot of botnets out there. You got the Assurai, you got the Doja botnet that's out there, but they're all kind of Mirai basic type of botnets out there. You see there we have sustained, so we have cluster almost 100 gigs of total averaging total throughput for attacks, which is pretty significant. Considering most people may have like a 1 or 2 gig pipe coming into their infrastructure. But you see there, just a lot of our high level metrics that we found. So I decided to look at from a temporal, time-based scale. So we uncovered a strong signature of automation and botnet behavior. Out of more than 35,000 valid IP movements. So this right here is looking at pair of IPs. So at least 2 IPs moving together at least once, right? So at least once a day, we've seen this at least 2 IPs moving between these two between botnets. And it's showing that many bots are reallocated daily in a continuous 24-hour cycle. So we're starting to see this cycle of botnet usage, right? Like I said earlier, they're not going to use 100% of their botnet for attack. They use percentage of it, but we're starting to see the cycle between these percentages. Other movements happened within that 1 to 3 days, which suggests that compromised devices are rapidly reused, but within a controlled operational rhythm. What's equally telling is what we didn't see, right? We didn't see no same-day reassignments and no very long gaps, which was kind of interesting. So it's a very short duration, very controlled, cyclical nature of rotation of these IPs. Like I said, this points to deliberate pacing and attackers' methodology, likely coded into automation routines that cycle through residual proxies, cloud assets, or leased infrastructure. That right there, think of like your AWS, your Azure, Linode, all these hosting things where I can go in, I can spin up virtual machines, very simple, very easy, infect it, and use that in my botnet. So the result is a predictable and tightly bound movement profile. It's not random or optimistic, giving us some behavioral signatures of the malicious actors. So from synchronizing the infrastructure as a whole, like I said, we found about 12.5 million plus unique IPs that we've seen, moving between clusters in a coordinated fashion. Like I said, it's large scale evidence of synchronized movements, which is a clear sign of coordination. While most of these pairs coordinate only once, more than 128,000 did so on 5 or more occasions, proving structured and recurring. Many of the most active pairs follow near weekly intervals, suggesting automation scripts governing reallocation. This behavior is not random overlap. It signifies tightly coordinated infrastructure designed for persistence. These persistent IPs are especially important. They're likely represented in nodes that attackers rely on more for reliability, load balancing, redundancy, and they might form like the backbone of their entire network, right? That might be the C2 server or some of these compromised devices that enable them to have that large scale type of attack. So think of like a virtual private center, VPC, that have terabits of network capability that they're using. So, so this right here moves beyond pairs and looking at group behavior. So that was like what IPs are kind of moving together. So we found 727 synchronized movements of that we recorded, instances where multiple IPs shifted into the same cluster on the same day. So multiple clusters going into the same, or sorry, multiple malicious IPs shifting into the same cluster. So very coordinated, very orchestrated shifting of IPs. Nearly 200 events involved at least 10 IPs moving at the same time, and 100 events exceeded at least 30 IPs moving, a scale that is almost impossible without orchestration. This group size distribution is telling. Smaller groups likely reflect testing or probing, while the largest group suggests reconfiguring a mass deployment. So we're starting to see malicious actors. They might use a couple of their bots to go out and test and probe defenses. I might use my low level bots to go out and see, is this site protected? Does this have a DDoS mitigation? Does it have a WAP that does layer seven, filtering? No, okay, then I'll go back to my bulk, my big botnet, my bots, and now use those for the attack. So what remarkable is we had a group that had 111 IPs maintain the identical movement over time, which was pretty interesting find. So extend precision movements. I think this is a repeat of the last slide. Okay, so sorry about that. So I'm also, once we identify these bots, I'm also taking them and I'm scanning them as well, trying to figure out what actually is this infrastructure of these bots. So we took about almost 62,000 IPs that like I said, identified as bots. So they meet that, seeing at least attacking 5 different organizations or customers at least once or multiple times. And then we nmap them. So majority of them were your standard service infrastructure. So 27,000 were web servers, 19,000 were Linux servers, which might be web servers as well. And then they're often hosted in cloud providers, right? Or repurposed environments. Routers and mail servers also appeared frequently, showing how attackers leverage compromised network gear or communication systems. Routers are a big target for malicious actors because a lot of people don't update their routers in their homes with firmware, the new firmware. So they become compromised pretty easily. Less common, but more importantly, were IoT and Windows systems, which could be hiding behind a NAT, a network address translator. So what that is, everything behind my home router, I have a bunch of IoT devices, but the internet's not going to see them because they're natted into that one IP that goes out, even though I'm running a 192.168 network within my house. So that obfuscates a lot of these devices that are out there. I expect IoT devices to be a little bit higher because, again, they're kind of built with ease of use versus over security. So, and then almost 10,000 were classified as unknown, underscoring the difficulty in fingerprinting infrastructure that uses some form of obscuration or proxy layering to kind of maintain and hide. So, okay, we did that. Then I was like, okay, let's start looking at the actual exposed ports that are out there. That can also help us identify what type of system it is based off of. So the first one was kind of looking at the header that you get from Nmap. This right here is actually going in and looking at the actual exposed ports that we have. So see right there, DNS was most detected, almost 20 over 21%. That can help with amplification type of attacks or covert C2. You got DNS tunneling and stuff like that. So that's kind of expected. HTTP, SSH, and FTP reflect exploitation of administrative accounts or administrative as well as legacy systems. And then you have your other FTP or administrative ports like 23, 22 show obfuscation tactics to deploy detection as well as enable backdoors into the system as well. So some of the future things, some of the things I've been thinking of how can we make this better is a little bit deeper port profiling, kind of uncovering those niche misconfigurements and role-based. Like I said, a lot of them are behind NAT or observated. So what can we do to kind of get around that and maybe find the true essence of the affected infrastructure? And then looking at, kind of mention it, we're kind of seeing trends and patterns of botnets. Part of it might be used for that probing or testing, and then the rest of it used for the actual attack. So seeing if we can actually go in and start characterizing the different roles within the botnet so we can identify, okay, the probing and testing. So if we start seeing that hit our network, that's an indicator, oh, something might be coming more. And then enriching it with additional threat intelligence out there, bringing in other open source or private intelligence sources out there to try to enrich the data more. And then keep looking at the trend comparison. So looking, like I said, that was April to June. We'll start looking at this from, a monthly or biannual or annual basis to see what is changing within the threat landscape with these bot clusters. And then infrastructure reuse detection, tracking recurrent IPs ports across clusters. And then, like I said, pre-staging is looking for those potential probing testing, low flags that usually come, or low noise that come in right before the attack. See if you can identify that as an indication zone warning for that. And with that, I will open it up for questions. Okay, good. Yep. Yeah. So attribution was one of the hardest things to do. For a couple things is a lot of infrastructure is co-shared um, between different organizations. Also, is Telegram is their go-to social networking thing, which I do have another project that scrapes and keeps track of known DDoS activism out there. But one day I might be wearing my KillNet hat and I'm doing attacks and I'm posting on Telegram. Yep, I did this. I log off, throw on my no name hat, and I'm using the same infrastructure, but under a different name. So it's kind of hard to do that. And then in order for us to actually try to do that association is we would have to see them claim an attack that goes through our platform and then see the actual attack. Then we can start saying, okay, yeah, then that was this group. And then we can start looking at the data for that, which is kind of hard to do. Another thing is we don't like putting out the actual in an open form of who does attacks because then we become a target. They're like, oh, you think you know us. So they start attacking our platform and our networks and stuff like that. So publicly, it's kind of hard to do, if that makes sense. Yeah. So I do a daily run of the clustering. I haven't sat down, and I haven't had time to sit down and so I did the April to June deep dive analysis. I haven't had a chance to continue that and look at to today, right? I, but yeah, that's the intent, is to kind of keep doing this over and over and to try to find, the more data we have, the more times we run through the clustering, the tighter we'll get, and then hopefully we'll start seeing more interesting things come out of it. But it's kind of getting rid of that single mind threat to more of a holistic behavioral thought process. So that is not something. That's not even something I even thought of. But that is not something we do not share our data because of privacy concerns within our customer base. But there might be a way for us to sanitize it, and kind of look at that, bring it up to my company, see if they're interested in and potentially uh, crowdsourcing stuff. But if you want the methodology, I can give you the methodology behind it. That's not proprietary; it's just the data itself. Yeah, yeah. So I have another project. It's called Open CTI. It's a open source CTI platform that there's actually a GitHub repository as well. Do like OpenCTI GitHub. There's a lot of data connectors, so a lot of open source databases out there that kind of ingest us all into a singular um, uh, interface, I guess you would say. That's what I'm looking at, is taking this data, getting that up and running, feeding this through the OpenCTI with all these other free data sources that are out there, and seeing what comes of it. What interesting things are coming of it? Have they been seen? Have they been flagged as? What other information we can find? So I don't. No worries. No, thanks for the invitation. This is actually my first true con, so appreciate it.
Awesome. Okay, so I think that's the last talk. We appreciate everyone for coming. Thank you so much for your time. We just want to also kind of give a brief announcement at the closing. We'll put a post out, but CarolinaCon will be postponed indefinitely after this con. This will be the last conference that we'll be running. So we hope you guys enjoy the CTF. We look forward to seeing who wins the CTF. Thank you for participating and engaging with all of our speakers. We had great speakers this year. Great material that was shared and posted. So thank you guys so much for your time, and we hope you have a great rest of your day.